Right now, the United States is dealing with about as active a weather pattern as you will ever see in the middle of summer. There are 4 or 5 distinct hazards playing out across the country, all at the exact same time. Let's work through this carefully because there's a lot to cover and every piece of it matters to someone watching right now. The most destructive of these hazards exploded over the Ohio Valley. A powerful, fast-moving cold front slammed into a deeply humid, unstable air mass. That collision forced warm air to rise and rotate rapidly, setting off a widespread outbreak of severe thunderstorms and multiple confirmed tornadoes across Ohio. Some of these were long-track twisters, powerful enough to flatten walls and scatter residential debris across entire neighborhoods. While those tornadoes were tearing through communities, the exact same storm system was wringing out extraordinary amounts of rain. In the greater Cincinnati area, water rose so fast that the mayor formally declared a state of emergency to manage the flooded streets. Widespread tornadoes and metropolitan flash flooding occurring in the same 48-hour window demonstrate just how highly energized the current atmosphere has become. This satellite view shows Tropical Storm Bertha down over the Gulf of Mexico. You can see the massive swirl of the storm system pushing directly into the Louisiana and upper Texas coastlines. While Bertha maxed out at 45 miles an hour, the real danger here is water, not wind. Forecasters projected storm surges up to 3 feet and isolated rainfall pockets hitting 6 inches. That volume of water quickly overwhelms standard drainage, turning low-lying coastal roads into rivers. Further inland, the rain side of the equation gets more complicated. A frontal boundary dropped into the Tennessee Valley and the Mid-Atlantic, but rather than clearing out, the boundary became quasi-stationary, parking itself in place. Locked in position, it acts like a ramp. Warm moisture pools along the line, triggering repeated heavy showers over the exact same communities day after day. When you combine slow-moving tropical storms on the coast with a stalled front inland, typical seasonal rain becomes a prolonged stress test for infrastructure. This pattern extends far beyond the Americas. Europe is currently working through an exceptionally intense summer. In Italy, red weather warnings have been issued for the south, with cities like Palermo pushing past 40 degrees Celsius, roughly 104 Fahrenheit. Businesses are doing whatever they can to mitigate the oppressive urban heat. This chart tracks daily temperature cycles to illustrate the hidden biological danger of a heat wave: unusually high overnight lows. The human body relies on cooler nighttime temperatures to recover from daytime heat stress. When that temperature line fails to dip into a safe recovery zone night after night, the cumulative physical strain climbs rapidly. That prolonged heat aggressively dries out the landscape. Near Orest, Spain, built-up dry fuel ignited into massive wildfires that scorched over 12,000 hectares of land, forcing over 1,000 people to evacuate. Looking further east, Central Asia is buckling under a similar extreme. Kazakhstan, Uzbekistan, and Turkmenistan are recording temperatures 6 to 10 degrees Celsius above their historical averages, pushing local daily highs near 45 degrees. As agricultural land dries out and demand for cooling spikes, this sustained heat shifts into a cumulative crisis that strains power grids and public health systems worldwide. While half the world bakes, the other is dealing with catastrophic volumes of water. In Vietnam, a single monitoring station recorded over 200 millimeters of rain in just 24 hours, triggering deadly landslides. Nearby, in South Korea, similar torrential downpours completely submerged urban highway infrastructure beneath thick, muddy floodwaters. Just to the west, India's monsoon season is delivering highly uneven and intense downpours. The rain falls in concentrated bursts across saturated ground, creating dangerous flash flood conditions that force dense crowds and vehicles to wade through knee-deep water right in the middle of city streets, while creating serious challenges for farmers. And yet, a few thousand miles away, the extreme shifts to devastating dryness. Across large stretches of East Africa, persistent drought conditions have wiped out local water supplies, leaving the skeletal remains of livestock scattered across the parched red earth. This geographic whiplash plays out across a single continent. While the East is starved for water, West African nations like Sierra Leone and Nigeria are under elevated flood risks, forcing residents to navigate chest-deep floodwaters over ground that is already thoroughly saturated. The global water cycle has reached a state of hyperpolarization, delivering these deadly opposing extremes to different corners of the globe simultaneously. So what global engine is actually driving all this simultaneous weather chaos across multiple continents at the exact same time? This map of sea surface temperature anomalies reveals a rapidly strengthening El Niño pattern, specifically that deep red band stretching across the equatorial Pacific. This temperature shift rewires the seasonal outlook for much of the southern hemisphere. A warmer ocean transfers more heat into the air, which acts like a giant sponge, pulling moisture upward and expanding the cloud layer's capacity. That moisture-rich atmosphere acts like high-octane fuel, releasing dramatically heavier, concentrated bursts of rainfall over the terrain below. That combination tends to load conditions towards more frequent and more intense extremes across multiple continents at the same time. From tornadoes in the Ohio Valley to deadly landslides in Asia and scorching heat across Europe, we are witnessing globally connected hyperactivity. Yet despite more than 116 million Americans falling under severe threat in a single day, the fatality rates remained remarkably low. When dealing with extreme weather, human intervention and preparation genuinely matter. Our primary defense against a heavily loaded atmosphere relies entirely on strict building codes, rapid early warning systems, and constant public weather awareness. Adapting to an environment defined by escalating extremes has become a permanent requirement for community survival.